Very good morning, very good afternoon, very good evening, everyone, guys. I hope that all of you are doing well, and I hope that all of you are doing great, guys. My name is Deepak. I have 15 plus years of experience in the same domain. I have designed, developed, implemented solutions for various cloud organizations as well. In addition to that, I have certain patents in my name. So, guys, and I'm also one of the lead instructor with Edureka. Having said that, let's take a look at what are the different topics that we're going to cover today. Today we will talk about why Google BigQuery, why it is being required, what is the use case of having it, and why we need it. What is Google BigQuery, BigQuery features, its architecture, overview of BigQuery storage, and ingesting data into BigQuery along with the pricing. Now, guys, if you're highly interested to take the training from us, this is going to be the course structure. The topics that we are going to cover end to end. So in the very first class, you're going to learn about GCP. What is Google Cloud Platform? What is cloud computing? What is the need of it? Different type of cloud computings you have. Like, for example, Amazon has an offering of their cloud, which is known as AWS, Amazon Web Services. Microsoft has the offering of their cloud, which is known as Azure. Google have their offering on their cloud, which is known as GCP. So you're going to learn everything. So you're going to learn this with the practical hands-on. In the second class, you're going to learn about managing GCP. So in this course, actually, you're going to learn that, what exactly is GCP, what is the advantage of having GCP, how you can manage. So let's say if you're going to deploy the GCP, how you can do the proper management with the practical hands-on. In the third class, you're going to learn about Google Cloud Platform virtual networks, which is one of the biggest myths. People think that in the case of cloud, you cannot create your own networks. Like the way you can create the networks on a on-premise environment, you cannot create the networks in the case of cloud, which is eventually not right. So you are going to have an opportunity wherein you are going to have the entire benefits, where you're going to see that how you can create your own network, how you can do the customization, how you can do automation, all these kind of things you're going to learn with the practical hands-on. Next one you're going to learn about is, security and identity fundamentals. What is the security? What is the identity fundamental? How you can basically automate this? How you can provide identity access management rights? All those kind of things with the practical hands-on. In the fifth class, you're going to learn about compute services, which is storage and all, with the practical hands-on and different type of storage offerings that GCP has. In the sixth class, you're going to learn about data storage services with the practical hands-on. In the seventh class, you're going to learn about architecting with Google Kubernetes Engine with the practical hands-on. In the eighth class, you're going to learn about application development with the practical hands-on. In the ninth class, you're going to learn about big data and AI services with the practical hands-on. In the last class, you're going to learn about automation. Now, if you want to automate, if you want to provide the automation on the components, how you can with the practical hands-on. And at the end, you're going to become a superhero like this. I would say superhero with the knowledge, guys. Now, starting with the first topic of the day, guys, what is GBT, which is known as Google Big Table? Before that, let's just talk about, why Google Big Table, like why we need it. So there are a couple of advantages, guys. So in the case of Google Big Table, the first is that it has a unique data warehouse services. So it's not like that you are going to have clustered and segregated warehouse. You are going to have a unique central hosted warehouse. And at the same time, this is ease for implementation. Plus, it's going to be, at a faster speed. Now, talking about what is Google BigQuery. Now, your Google BigQuery is a fully managed serverless data warehouse which enables scalable analysis over petabytes of data. Now, if you know, you have a KB, then MB, then GB, then TB, then PB. So it's that much huge space. So this is a PaaS, which is a platform as a service, which supports querying using ANSI SQL. Now, talking about certain big, features of BigQuery, there are multiple features that you get, guys. The first is serverless. Now, in this case, the good thing is that you don't have to deploy a server. You don't need a dedicated hardware. So it's like a pay-as-you-go service. You want to use it, just leverage the service, pay for your usage, and boom, you're done. So it's a serverless environment. There is no dedicated server which is being required. Second is a petabyte scale. So here in this case, you can store a lot of data, and you can just expand the infra the way you want. The third is real-time analytics. Now, if you want to have a dashboard or anything, you will be able to have the entire real-time analytics being available here for your use. Next is a flexible pricing model. Here in this case, if you want to change the pricing and as per your requirement, you're going to have the flexible pricing model. Next is automatic high availability. Now, if you want to create a cluster, you want to have dedicated clustered environment, you're going to have automated high availability available. Plus, you can do auto scaling as well, guys. Like if you're going to have more requests, it's going to scale up automatically. When you're going to have less requests, it's going to scale down automatically. Like for example, If on your application, let's say CPU utilization is going to go beyond 90%, then in that case, it's going to scale up the environment automatically. When the CPU load is going to be less than 90%, then in that case, it's going to scale down automatically. So all such kind of things you can also do here at the sake of ease. Next is data encryption and security. Data encryption, guys, what you do is you are just going to change the form of the data so that only the authorized people can understand that data. Like here in this case, you are going to encrypt the entire data with a single key. And once the data is going to be encrypted, it's going to be in a gibberish format. And in order to decrypt, you will require the decryption key. So you can perform encryption and decryption via that. Now, at the same time, other is standard SQL. Now, here in this case, you are going to have a standard SQL service, plus you have a foundation for AI, which is artificial intelligence. If you want to use, you have the foundations for it. Plus, you have the foundations for BI, which is business intelligence. Okay, guys. Now, moving on. Now, we will talk about the architecture, like how exactly the architecture of BigQuery looks like. In the case of BigQuery, guys, like you have basically different components which are being combined together. Like you have Colossus, Jupyter, lead nodes, mixer, root server. Now, in this entire diagram is an entire separate discussion. If I had to explain, it's going to take a while. Now, just to make it easier, in this case, one of the biggest advantage that you're going to get is like, you are going to have all the clustered together. Now, if you want to integrate with any of the component, any of the services, you can just do that at the sake of ease. And at the same time, if I have to tell you about BigQuery storage, just an overview, because if I will go in detail, then we require more time. In the case of BigQuery services, you have, let's say, two projects. Project X, let's say it's a part of your company. Project Y, it's a part of your, let's say, different company. So let's say these projects can be in a same domain or a different domain. It can be part of your company or it can be part of a different companies as well, wherein you are going to have different assets. Like you are going to have tables, you are going to have, different data sets that you are going to have. Now here in this case, if you want, you can create a cluster. Like here in this case, the project X that you're going to have, here in this case, data set, the first data set that you have, data set A can cluster with data set C. Likewise, database B, data set B, can cluster with data set D. Now, let's say if in this case, project Y side goes down, the domain goes down, then in that case, your services are still going to be available, which is known as high availability clustering, where if the one nodes go down, your services are going to be still up and running. That's the way the Google works. Like if you go to Gmail, are you going to get a downtime on that? Like, is it going to happen that they are going to, post on their wall, today we have maintenance from 12 a.m. to 2 p.m. Its service is not going to be available. You have never seen, right, on Google. The way they do like is they create a cluster at the nodes, wherein the nodes which are not going to be, used or required, just maintain them first, and likewise just go one by one so that you have that high, availability being maintained. In the case of storage management, you can have two type of storages. Either you can go with a traditional RDMA storage, which is a row manner, which it's very tedious, complicated, takes time to implement, or the column level, where you can just go column one by one. Now, in the case, if I talk about in terms of storage management, let's say if I have different regions. Now, in this case, I can just store data at different locations, and it's going to be applicable for all the people. Now, like I said, guys, like wherein if the one side is going to go down, your still services are going to remain up and running. Now, if I talk about LTS, which is long-term storage, so if you have a table or a partition that is not modified, let's say for 90 consecutive days, it is going to consider as long-term storage, and the price of storage for that table automatically drops by 50% to the same cost as cloud storage nearline. Because in that case, your Google is going to archive that solution. So it's not going to be actively available. That's why it's going to drop the cost by 50% automatically without your intervention. Now, in the case of data ingestion, if I talk about, we can have three type of data ingestion: batch ingestion, streaming ingestion, and DTS, which is data transfer service. In case of batch ingestion, guys, it involves in loading large amount of data that does not have to be processed. They are typically ingested at specific regular frequencies, and all the data arrives at once, or it does not arrive at all. Where in the case of streaming ingestion, guys, if I talk about, like you are going to have real-time events wherein you are going to have your entire data being forwarded at different locations, and you can just club them together and you can use it for the application. Like for example, if I have data coming from 20 different applications, I can just combine into a single package and I can use it for my reference at the sake of ease. Where in the case of DTS, data transfer service, the BigQuery data transfer service is an entirely fully managed service to ingest data from Google SaaS application like Google Ads, external cloud storage provider, Amazon S3, and transfer data from data warehouse technologies such as Teradata and Amazon Redshift. Now, in terms of pricing, guys, if I talk about it, has a very great pricing model. Either you can have analysis pricing where you can have either on demand, like whatever the kind of thing that you're going to use, or a flat rate pricing. Now here in this case, if you're going to pay in a other currency than USD, then the prices listed are going to be on your currency. It's going to apply then in that case. Where in the case of analysis pricing model, you're going to have flexible slots. You're going to have monthly or you're going to have yearly, depending on your requirement. Or you can just go with the storage pricing, where instead of billing as per the usage, you are just going to bill as per the storage. So in the case of active storage, if you are actively using it, like for example, I'm using it from my application on a daily basis, the cost is going to be high. And if I'm going to, let's say, not using it for a long time, like for example, I want to archive this solution, I want to store the backups. Like, backups are not going to be used frequently, right? I mean, if I'm going to make something as a backup, I'm not going to use it for a long time, right? Just for example, guys, like if you have a backup in your hard drive, how frequently you access those backups? Once in a blue moon, right? So the same thing happen in this case. So if you are going to use this on a regular basis, then in that case, of course, the cost is going to be high. And if you're not using it, let's say for a long time, then in that case, it just dropped down the cost. So automatically it's going to become LTS. So wherein you have seen that where the cost is going to be dropped by 50%. For example, if I'm paying $1,000 for my something which is stored in my system, here in this case, I'm going to just pay, let's say $500. So I'm going to get flat 50% discount. So that's one of the biggest benefit that you get in that case. Like instead of paying it for something that you're not using, here in this case, you can just save the cost and at the same time, you can just save the effort and you can recoup that cost for something else.
Thank you so much for joining today's sessions, guys. Wishing you a great day ahead. Bye bye. Take care.